Welcome to Lecture 12, the final lecture of this course, entitled Sustainable Futures, with a question mark after that title. Why the question mark? Because I want to ask the question of how might we build a sustainable future, a future in which we have a stable and benign climate, one that doesn't cause all kinds of disruptions and dislocations for the various species that live on Earth, including particularly our own. So what's our goal here? We're faced with the problem of anthropogenic climate change caused by human activities, predominantly the burning of fossil fuels for energy, but also other activities as well. Well, humankind as a body has in fact articulated a particular goal, and that goal was articulated at the 1992 Earth Summit in Rio de Janeiro, which started the process called the United Nations Framework Convention on Climate Change. The Kyoto Protocol, which you've surely heard about, is a sub-aspect of the UN Framework Convention on Climate Change. So what is the goal? Well, the goal, as quoted in the UN FCCC, as it's called, is, with regard to climate change, our goal is, quote, stabilization of greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic influence with the climate system. So we're trying to prevent dangerous anthropogenic influence with the climate system. That's all well and good, but what is dangerous anthropogenic influence? Well, that's a matter of some debate, but not a whole lot. Most climate scientists would suggest that somewhere around a doubling of pre-industrial carbon dioxide, we reach a level where the interference that humankind has made with the climate system, in other words, the climate change that will have occurred as a result of a doubling of pre-industrial carbon dioxide, that will be dangerous in the sense that it will be disruptive to the systems like agriculture that keep us going, to the marine ecosystem, to the climate that keeps us healthy, and so on. Somewhere around a doubling of pre-industrial CO2 concentration will result not just in unpleasant climate change, some places it will be pleasanter, but some places it will be unpleasant, but will result in real dangers to human societies and to other species as well. Now, I want to pause a minute and say something right at the outset. I personally don't think global climate change will ever be the kind of disaster that, for example, an all-out nuclear war would be, or a strike from a large asteroid, or even a moderate-sized asteroid. These are things that are potentially civilization-destroying events. I don't think global warming fits in that category. There are some people who would argue it does and who are very alarmist about it and think this is an enormous crisis. I think it's a big crisis, possibly, but I don't think it's a civilization-destroying event. For one thing, it's happening rather slowly unless one of those surprise events occurs. It's something that we can adapt to. It may not be very pleasant to have to adapt to it, but it's something the human species and human civilization can survive. That doesn't mean I think it should be allowed to happen, but I don't rank it in the same category as an all-out nuclear war or an asteroid impact. But most scientists would argue that somewhere around, again, a doubling of pre-industrial CO2 is where we really get dangerous with climate change, with anthropogenic influence on climate. Some would argue that the threshold is probably a little bit lower. Some might argue it's a little bit higher, but if anything, some would argue it's lower. Now, remember what the pre-industrial concentration of CO2 was. Remember my milk bottles. The pre-industrial concentration was about 280 parts per million. Today it's around 390 parts per million. A doubling is twice 280 or 560 parts per million. So we're partway there, but we're not anywhere near all the way there. On the other hand, CO2 concentrations are going up by about 2 parts per million every year, and that rate is almost certain to accelerate as developing countries, particularly China and India, rapidly industrialized. China particularly has huge resources of coal, and that's the quickest way for them to get up to our kind of standard of living, by burning a lot of that coal, particularly to make electricity. Now, we've already looked at some graphs that show the CO2 emissions and the resulting temperature changes under several of the IPCC scenarios for what humankind might do. For example, we saw an enormous variation in the CO2 emissions between the A1FI, the fossil-intensive business-as-usual scenario, and the more environmentally friendly scenarios of the B categories. Big differences in the amount of emission. We saw rather less difference in the amount of temperature change, because the temperature change depends not on the instantaneous rate of CO2 emission, but on the accumulated CO2. What if you look instead at not the CO2 emissions or the temperature change, but rather what the CO2 concentrations might be in each of those scenarios? Well, if you were to look at what the CO2 concentrations predicted by the year 2100 are in those scenarios, you would find that, for example, the A1FI, the fossil-intensive business-as-usual scenario, predicts the highest level of carbon dioxide concentration at the end of the 21st century, almost 1,000 parts per million. That's in the range of what we think was the CO2 concentration during the time of the dinosaurs, when much of the Earth was tropical in climate. That's at the end of the present century in the A1FI, the fossil-intensive scenario. That's clearly well above, by almost a factor of 2 above, the doubling of pre-industrial CO2 to about 560 parts per million that most climate scientists would regard as dangerous anthropogenic influence on the climate. Many of the other scenarios, the A2 scenario, for example, the scenario that involved a non-globalizing world but still with emphasis on economic development, a world in which the population continues to grow to the year 2100, that one doesn't produce quite as much CO2 concentration as the fossil-intensive business-as-usual scenario, but it gets us up to about 800 parts per million. And several of the other scenarios also get us up above 600 parts per million. In fact, only the most benign scenarios, the B1 scenario is the most benign. The B1 scenario is the scenario that says we're going to be a globally oriented world, but we're going to put our emphasis on environmental protection. That scenario is the best, and it gets us to about 500 parts per million, give or take a little bit. It gets us a little bit below that threshold, but just barely, for dangerous anthropogenic influence. And who knows whether that's a sharp threshold or a gradual thing. Even that may be too high. The next best one is the A1T scenario, the economic development-oriented world that is globalizing but uses advanced technology to replace fossil fuel combustion. That one gets us to somewhere between 500 and 600 parts per million, just about in that pre-industrial doubling range. So, of all those IPC scenarios, those storylines, those projections for how humankind might behave in the future, only a couple of them, maybe 3, get us in the range of that 560 parts per million doubling at the end of the 21st century. And for one of those 3, the concentration is still continuing to climb at an increasing rate. For the other 2, the A1 technological scenario and the B1 scenario, the environmentally friendly scenario, they are both leveling off by about 2100 at levels approximately twice the pre-industrial concentration. So those look like viable scenarios for meeting our goal, if our goal is indeed to avoid, quote, dangerous anthropogenic influence with the climate system. So how do we get there? We're not headed there now. I want to emphasize that. We are headed toward the combustion of more and more fossil fuels, and over the next couple decades, it looks like a lot more big power plants, coal-burning power plants are going to come online. It looks like a lot more people are going to have cars run on fossil petroleum. It doesn't look very good for getting off that A1 fossil-intensive scenario, yet that's what we've got to do. Given that the dominant anthropogenic influence on climate, the thing we're trying to avoid, a dangerous anthropogenic influence on climate, is from the combustion of fossil fuels, we really have 4 different ways, as I see it, to avoid that influence. Some of them I mentioned briefly. I'm going to go into more detail on them, and some of them I haven't even talked about yet. So here's one. And I haven't mentioned this at all, and I'm going to be pretty dismissive of it. We could devise global engineering projects that compensate for the upsetting of the Earth's energy balance by fossil fuels, particularly fossil greenhouse gases, carbon dioxide and methane, by upsetting the energy balance in the other way to compensate for that. We could keep burning fossil fuels as much as we wanted, but we could do things like, for example, injecting sulfur particles into the upper atmosphere. This has actually been suggested. Seed the upper atmosphere with sulfate particles. Serious papers in the scientific literature have been written about this. Put just the right amount to reflect enough sunlight to compensate for the enhanced greenhouse effect due to fossil fuels. We could place mirrors in orbit to reflect incoming sunlight and reflect just enough incoming sunlight to compensate for the increased warming, again associated with the greenhouse gases. We could seed the oceans with iron. Most of the open ocean is a vast desert. There isn't much life there, and one of the reasons there isn't much life there is because there's a dearth of nutrients, in particular iron. And if we seeded the oceans with iron, we could cause the growth of phytoplankton, plankton that do photosynthesis, tiny marine plant organisms that do photosynthesis, and they would take up carbon dioxide out of the atmosphere, and we could remove some of the carbon dioxide that we put in. Those are 3 of a number of examples that have been proposed of what I call global engineering projects. We're trying to re-engineer the whole Earth system. And I personally, as a scientist, don't think they're very good ideas. And I don't think they're very good ideas because the Earth system is very complex and we don't fully understand it yet. And we are doing major tinkering with it, with any of these approaches, and we don't know if they're going to backfire, if they're going to trigger positive feedback mechanisms that make things worse. We don't know enough to know how those global engineering projects would really work. And I think it's dangerous to play with planet Earth in that way. And so I'm going to dismiss that as one of the options. Proponents of these options would argue differently, but I don't think global engineering is the way to solve the problem.